Welcome back to Island Biogeography Rebuilt here with sound. Really awesome. Okay, this time we're going to talk about part 2, the shifting of the curves. Now, again, I have a nice graph here where I've labeled colonization on that side, extinction on the right side. And what we see here is extinction. And I've labeled carefully each of my lines so that I have colonization labeled and extinction labeled on there. Now we're going to talk about what happens when something fundamental changes, like you're looking at a different set of islands. When you're looking at a different set of islands, you have to predict, again, the model's goal here is to predict the number of species on that island as the result of ecological interactions. And we've said it's a trade-off between colonization and extinction. We have an equilibrium point here in the middle. That feels pretty good. But now what happens if the island is further from the mainland than predicted? Than the other island. So let's look here on the right-hand side. I've got these two descriptions. If you're close to the mainland, you're going to have more colonization. That just means more organisms. I always like to imagine birds coming off of the mainland onto the island. And think about this as a fire hose of like pressure hitting the island with new species, right? And as this occurs, you're going to have more colonization for every given island, right? And if you're further away, you're going to have less colonization. Again, remember that colonization is actually not only arriving, but actually settling there and surviving. And so let's go there, and then I'm going to make a new line on here, which is going to be this lower colonization rate for a further island away. So I'm going to make a dashed line here. Now, the way we depict this is that the entire curve shifts. Okay, so this is going to be a far island. And that makes the other one, by default, the closer island. And now we can see there's a new equilibrium point here. And the new equilibrium point will, of course, have a lower, this is a far island, right? So it's going to have a lower number of species. So we've seen a shift to have fewer species because the rate of colonization is smaller. If, for example, we look at extinction rates, which could... and the extinction rate tends to vary with the size of the island. The extinction rate does not vary with the distance of the island. That only affects colonization. But the size of the island, so let's take a look. If we have a large island, we tend to get more species, more niches, more space, larger population sizes, all that stuff. But it's all the same at every level of S. And then if you're a smaller island, you're going to have fewer species. And that's, again, because smaller population size, less resources, smaller amount of space, period. So I'm going to make a curve out here that, let's say what happens, the extinction rate will decline for an island that is larger. So let's go put a larger island. And that makes this one, by default, the small island up here. And then for the large island, what we see is a reduction in the extinction rate. Now, it's important to think about which way the curve goes. Remember, when the curve shifts to the right, like this one's doing, that means that there's going to be a higher equilibrium level of species, right? So there's going to be more species on the island. So this is S for a large island. And this particular island in this equilibrium point is actually, and I'm going to circle it in green, this one is large, and it's also for a relatively near island. So you can see that a large near island has the most equilibrium number of species, and one that is on a small island and far away has the lowest equilibrium number of species. So these are the two extremes here, but of course you could have any different one of these 4 equilibrium points. And of course there's an infinite number of points with different sizes of islands out there. So, but the big one and the small one are probably the most important. So this is how curves shift. Notice I didn't change the slope of the curves. In your book or in other places, you'll see the curves are driven, they're drawn as being curved, which is perhaps more precise because the number of species is not perhaps linearly related with the extinction and colonization rate, so that's okay. These straight line curves are easier for us to draw and easier to work with for this class. Enjoy.